A list of the equipment you'll need for this experiment. First, you'll need some ductile materials such as Play-Doh. Oh, look at that. Next, you'll need an appropriate measuring implement such as this 30cm ruler. Wow, that's nice. Next, you'll also need a chopping medium for your material. In this case, we've used a wooden chopping board. This is appropriate because we're using Play-Doh. Wow, look at that. You'll also need some probes. Wow. And a compatible digital multimeter. This multimeter will be used to measure resistance, so your probes will be plugged in here and here. Please note that this may be different on some devices. You'll also need a digital caliper or other more precise measurement device. This will be used to measure the diameter of your material. In addition, you will also need some graph paper to draw a graph of your results, and some line paper. This will be used for a results table. Now you're all set and ready to measure the resistivity of a material. The risks associated with this experiment. Luckily, there are no risks. To take your material and roll it into a long, thin wire. Here's one we made earlier. Okay, so we have our wire. What do we need to do next? We need to measure the length of our wire, and remember, we will be changing this accordingly, so we will have to repeat this process. In this situation, our wire is 30 centimeters long. We have measured this using an accurate instrument. Okay, so we've measured the length of our wire. Next, we need to choose a more accurate instrument, such as the digital caliper we told you to prepare earlier. Okay, so what we're going to do now is measure the diameter. This will be used to calculate the cross-sectional area of the wire. To ensure this value is accurate, as it will remain constant, we will measure the diameter in 3 places and take an average. Okay, now here's my glamorous assistant demonstrating how. Well done. Okay, now you need to record your 3 values and then calculate the cross-sectional area. Now we have our equipment, let's start with the method. First, you're going to need to draw a results table on a lined piece of paper. Oh look, here is one I've made earlier. Your results table must have length and resistance in it. We can measure the length of our wire initially, and then we'll record the resistance using our multimeter. Okay, now we've recorded our 3 diameter values and taken an average. The first thing we need to do is convert our value into meters. This is done by multiplying by 1 times 10 to the minus 3, or dividing by 1,000. This gives an answer of 0.01307 meters. Okay, now we need to take this value and divide by 2 to work out the radius of our wire. This gives us a value of 0.006535, or 6.535 times 10 to the minus 3. Okay, now we need to work out the cross-sectional area of our wire. As you might know, the formula for cross-sectional area is pi multiplied by r squared. So, first we need to square our radius and then we'll multiply it by pi. If you do not have a calculator, you may take pi as 3.14. This gives a value of 1.3417 times 10 to the minus 4 meters. This value is important, so keep it recorded on your results table. Okay, now we're ready to move on to our actual experiment. First, we must prepare our multimeter. Okay, now note we are going to select the appropriate measurement of resistance for our material. We have selected to the order of 200 kilograms, as Play-Doh is very resistive. Okay, now, my glamorous assistant will insert the probes into the multimeter and then into the Play-Doh. Just like that. Okay, our reading, 41.5 kiloohms. It was important that we took this reading fast, as the resistance of Play-Doh steadily increases as it is kept idle. See, this is shown here. Okay, now we record the result in our results table. This is our results table. As you may be able to see, we have made a little bit of a mistake. We have recorded 41.5, the value shown on our multimeter. However, we specified that we would be recording our resistance in ohms, and the 41.5 was in kiloohms. This is an easy mistake to make, so be sure that you're recording things in the right unit. Okay.
That was a bad angle, wasn't it?
Next, we would record results for all chosen lengths. However, to avoid boring you, here's a set we prepared earlier. Okay, here's our results. Now, this is the formula for resistivity, which we will use to calculate the resistivity of our material. Here is a rearrangement of this formula. Now, note what we have recorded. Resistance and length. And we've also calculated the cross-sectional area of our wire, which will remain constant. Okay, now we'll plot a graph of resistance against length. This will give us a gradient of R divided by L. And we can work out the resistivity by multiplying this gradient by the cross-sectional area of our wire that we calculated earlier. Okay, now, we could bore you by drawing a graph, but here's a graph that we made earlier. Okay, this is our graph, but we've made a mistake to test you out. Can you spot what it is? We've plotted length against resistance, and this is the wrong way around. In our calculations, however, we'll be using the gradient as normal, R over L. Okay, now I'm going to hand over to my glamorous assistant, Abby, to perform the calculations. This is the cross-sectional area, and to work out the final value for our resistivity, we're going to need to calculate the gradient. As we've already explained, this will be R over L. Wow, this is a beautiful calculation. Whoa, gotta love that graph. Okay, now as you can see here, we've noted down the resistance in kiloohms. Brilliant. Now we're going to calculate our gradient and then multiply it by the cross-sectional area to give it a final value for resistivity. Wow, that's how it's done. Wow, that's how it's done.
Damn it.
Wow. Totally professional. As you can see, even us science masters still make mistakes. Wow, that was beautiful. You know what? I'm gonna go off and watch some anime. Thanks for listening, guys. We hope you enjoyed this. That's goodbye from me and...
Me? No, don't!